Day 3. What's today? January 13th? Oh yeah, it's Friday the 13th. Spooky, spooky, bad luck and all that stuff. Yes, go watch a scary movie tonight. So today we're going to do period changes. I think we wrote this at the end of yesterday. A times sine of B times x minus c plus d. And just as a refresher, what does A control? The stretch and maybe the flip, so we know what A does. B, we haven't really talked about yet. That's going to be today's. Let's go ahead and label it while we're here. So A is the stretch, maybe the flip. What does the C control? Good. This shift. Careful, don't do this way. Do the left-right shift. And what does D control? The up and down shift or the vertical shift. So what we haven't talked about yet, because it's the hardest thing to worry about, so we saved it for a day to itself, is how B affects the period. We saw that on the Desmos thing where it stretches it or squishes it, but that was just with the slider and getting the idea. Today we'll learn exactly how it works. So B controls the period. Let's look at how it controls the period. Here's the graph of sine. The period is 2 pi. That's the normal graph, or that's the normal period for sine and for cosine and for their partners. But if we stick a 2 in there, the period becomes pi. So as B gets bigger, the period gets smaller. Right, as B gets larger, the graph shrinks in. That's exactly right. That's a lot of words in that next box. The most important part of that box is that the period is the normal period over B. So what that means is this statement. For sine and cosine and secant and cosecant, those all have a period of 2 pi. So the new period, the translated period, is 2 pi over B. But for tangent and cotangent, the new period is pi over B. But rather than try to memorize like 2 equations, you just know the main idea that it's whatever the normal period is divided by B. We'll tell you the new period. So some examples. Find the period of y equals 4 sine 6 parentheses x plus pi over 9. So that would be a real pain to graph if we wanted to graph that, because you have to go left pi over 9. But we're not graphing it. We just want to know what period is. Well, the period is 2 pi over B. B is 6. So that period would be pi over 3. Number 2 would be even crazier to graph because it's stretched by 7 and flipped and moved up 2 and right 5 pi over 9, but that's not what we're concerned about. We just want to find the period. Fraction. See if you can figure out what that is. You need to hit pause, I bet. 2 pi over 1/3. What does that turn into? Two pi divided by 1/3? 6 pi. Keep it, change it, flip it if you need to. 6 pi. And so, yes, if the number is smaller, if B is less than 1, it stretches it out. If B is bigger than 1, it squinches it up. Squinch being the official math term for what's going on there. Number 3. Find the period of y equals 1/4 tangent of 3x minus 2. Okay, what's different about this one than 1 and 2?
It's pi over b.
Yeah, it's pi over b because we're dealing with tangent. So period is pi over b. This was a little bit different. What's b equal to? Which of those numbers is b? 3. So this period is pi over 3. Number 4? You try number 4. So that period is 6. Number 5, a little bit of a backwards problem. Given that y equals 3 tangent b x minus 2 plus 5, for what value of b is the period of the function 2/7? Okay, well, period is still pi over b. I don't know what b is, but I do know what the period is. So it's the same formula, but a different thing we're looking for. So 2/7 equals pi over b. What will I do to solve for b?
Isolate it.
And how will I isolate it? You're right. If I divide by pi, I would have 1 over b. So you could do it that way. I think most people are going to just cross multiply. That way you don't have any more fractions to worry about. So 2b equals 7 pi. And then b equals 7 pi over 2. Number 6, same type question. The period is 8. What is b? We got sine, so we're back to 2 pi over b. So 8 equals 2 pi over b. So I'll let you algebra experts mess around with that and see if you can figure out what b is. So there's our sort of information. Now we got to translate or get all of that information onto our graph. You might remember that we usually do the horizontal and vertical shift together to make our new origin. So no horizontal shift, but down 2. Now, be careful on a completely blank graph. It's like, well, how far down should I make each axis or each mark? Excuse me. So you kind of have to look at the vertical stuff together. So I want to go down 2, but my amplitude's 2. So that means, let's see. That means I'll be going between 0 and 4. There's my new origin. Going down 2, handle the horizontal shift. My period is 10 pi. So I know sine starts at the 0, and it starts over 1 period away. So 1 period away, if I want it to start over right there, then I need to make that 10 pi. All right, well, what would be halfway between 0 and 10 pi? 5 pi. And where will my graph be when x is 5 pi? It'll be, just say, is it a minimum? Is it in the middle, on the midline, or is it a maximum? Midline. It's on the middle at 5 pi. And then halfway in between those, that's 2.5 and 7.5, so I'm not even going to label them. I'm just going to put it halfway. At 2.5 pi, it's at a maximum. How high is the maximum? How far above the midline is my maximum? 2, because my amplitude is 2. And then same type thing with the minimum. So there's my graph. Usually we want to see 2 cycles. So I want to extend that back. I mean, I guess you could extend it forward, but then I'm out of paper. So let's extend it back. So I'm going to copy that back 1. So I'm going to try to make these, my spacing the same so my graph doesn't look funny. So I'll need to go back to negative 10 pi. Negative 5 pi will be a 0. And then the halfway points are mins and maxes, depending on where we're at. Now, we really have done all the new concepts that we're going to do for the week. When we come back next week, Tuesday, given parameters, write the equation. So on Tuesday, I'm going to give you this information and have you write the equation. On Wednesday, I'll give you the picture and have you write the equation. On Thursday, we'll review, and on Friday, we'll test. So if you've got it in your brain already, then you're good, but we realize that it takes a few days for all this stuff to sink in. All right, try number 8. So fill out the 5, and by try, I just mean fill out the 5 characteristic things, and then we'll pull some popsicle sticks. So there's our characteristics. If I want to go write pi, I need to be careful, like how far over do I want to put pi? If my period is 4 pi, then be careful. I don't want to put pi way over here, because then 4 pi would be, or 4 pi away would be way off the page. So I'm going to put pi kind of close in for this one, because I need to go 4 pi away to get to where it ends. In fact, while I'm thinking about it, I might do that right now. 2, 3, 4, 5 pi. So 5 to 5 pi, that'll be the window we look in to see our cycle. Down 2. You okay over there? I want to go down 2, but I need to be careful because my amplitude is 3. So that means if I go down 2, I've got to be able to go down 3 more to get to the minimum. So, I don't want 2 to be down here because then I'm way off the page. So about right there, I guess, looks good, because then I can go down 3 more and be at negative 5. And so write pi down 2, there's my new origin. Let me do my mini parent function here. Cosine normally looks like that. So my first point on my new graph, after I've done all the things to it, is it going to be a minimum, a maximum, or a 0? Oh, I heard min and max. Why minimum? Yeah, flipped is the key thing. So my used to be max is now a minimum. And my minimums are 3 down. 1, 2, 3. So there's my new point A. And again, I like to do the first and last point first, because then I know sort of what I'm looking at here. So over at 5 pi, again, 4 pi away, we'll have another minimum. So I got to fit my graph in between pi and 5 pi.
So like the difference is the last couple of days our period of like graphing has only been 2 pi, but now we're just switching it.
That is exactly right. The last couple of days our period was always 2 pi. And so we tried to get used to making all the other moves, but holding 2 pi the same. Today we're changing everything. All right, so halfway in between a and b on the parent function is a minimum, but on my flipped function it's a maximum. Halfway in between 1 and 5 would be 3. Where is my maximum going to be? Where am I going to put the point? 3 up from what? 3 up from the new origin. So 1, 2, 3 up would be a maximum of 1. I think I did this yesterday. Some people will put in the whole set of axes, especially if there aren't asymptotes to worry about. Halfway in between A and C is a midline point, but on the new midline, on the new x-axis, not on the actual x-axis. And same thing, halfway between B and C is a midline point. I want to see 2 cycles. Okay, so I need to extend it back. If I start at pi and end at 5 pi going forward, where will my ending spot be going backwards? If I start at pi and go 4 pi backwards, negative 3 pi. So that'll be my next starting point, or my next start over point. And then again, it's the same process. Halfway in between is a maximum. Halfway in between there is on the axis. And there's my 2 cycles. And probably a good idea to go back and make sure we did all the things we said we would do. It's definitely flipped. It's stretched by 3. It's right pi. It's down 2. And the period is 4 pi. If you could do number 8, you could pretty much do anything the rest of the unit. Because number 8 had all of the problems that you could have were on number 8. Number 9, last one, tangent. Ooh, I'm going to, just because we hadn't done a tangent today, do the baby parent function there to get it in my brain what tangent looks like. Great way to take attendance. Get to almost everybody today. All right, Derek, vertical reflection, that's just a yes or no question. No. Noah, vertical stretch? No. Usually we don't do a vertical stretch on tangent because it doesn't really make it look different. Right? If you stretch out those weird graphs, you can't really tell by looking. So we usually don't bother with a vertical stretch. Uh-oh, I got these popsicle sticks mixed up, so I don't know who was where, but Austin, a horizontal shift? None. Good. So that's a great start. No, none. Cole, vertical shift? Up 1. And Landry, the period? Good. Pi over 2, because it's the normal period divided by b. So pi over 2. Okay, vertical shift up 1. So there's my up 1. And again, if you want to put in the whole new axis, that's fine too. Tangent usually starts at 0. So there's a 0 right there. And then how far away is the next 0? I mean, it's usually pi away. But today this problem, it's pi over 2 away, because the period is pi over 2. So somewhere over here, I'll put pi over 2 and put another point there. And put one on the negative side as well. What happens in between the zeros of a tangent graph? Asymptotes. So there's my graph. That one was tricky because we don't do a lot of tangents, but it didn't have too many changes to it, so that wasn't too bad, I hope. All right, this long weekend assignment, long referring to the weekend, not to the assignment, is worksheet 3. So there's 10 questions. 7 of them are multiple choice property type questions, and then the last 3 are all the graphing stuff. So give those a try, and if you're able to do worksheet 3, you're probably going to be just fine next week. It's really next week is all review.